Well, welcome to Module 5, and we're going to start the journey today with this great picture. You've seen those signs that says you are here. Well, this is actually a picture of planet Earth in the middle of a beam of light from the sun that was photographed by Voyager 1 back in 1990. Some people refer to this picture as the pale blue dot. Okay, now just to give you an idea of the significance of this, so this is a kind of a top-down view of our solar system with the sun in the middle and the various planets. And as you can see, we've got a position where Voyager 1 was in each of the years, and where it was sitting in February of 1990 was out past the orbit of Neptune. So it was about 3.75 billion miles away. Okay, and we know light's fast, but it's so far away it takes light about 5.5 hours to travel that distance. But even from that distance, we can see that the Earth is blue. Right? And in your textbook, Dr. Wild did a nice job talking about this. But why is the Earth appear blue? Well, that's because about 71% of it is covered with water. Which leads us to what we're going to talk about today, the hydrosphere. And the hydrosphere is really, it's all the water that's on our planet Earth. But it's not all in one place. It's actually distributed. There's oceans and lakes and ponds and rivers and creeks and, lots of different places. We got the clouds up in the sky. We got icebergs and glaciers, right? And if you remember from last week, from Module 4, we looked at some of the amazing properties of water, right? There was the polarity of water. The fact that it's the almost universal solvent. The fact that ice floats, that it's liquid at room temperature. And then because of that polarity leads to hydrogen bonding, we get that cohesion, that tension, right? That as a bare minimum is great for the plants because then they can pull the water up into them where they need it, to create more and bigger plants so that we have food to live on, right? Anyway, so did you know that of all the planets in our solar system, Earth is the only one that has a large quantity of water that's in its liquid form. And liquid water is essential for life. And so what that means is Earth is actually a big deal. Now, the other cool thing is that where the water sits, most of it, the water sits, the temperatures range from about 32 up to about 212 degrees, which allows water to be a liquid. And that liquid water is essential for life. But did you know there's basically two things that determine the temperature of a planet? First is its distance from the star and what actually makes up the atmosphere. So here's a graphic showing our distance from the sun. Right? We've got the inner planets. We got Mars and Mercury and Venus between us and the sun. We're the third planet out. And we sit in what's known as the habitable zone. Okay? It's also called the Goldilocks zone. And it's called that from the children's story about Goldilocks and the Three Bears, where things needed to be just right. And so where Earth sits relative to our sun, it's far enough away that it's warm, but it's not too hot. And it's not too cold. It's just right. Now later in the course we're going to look at stars in a little more detail. But since we're talking about the habitable zone right now, here's what the effect of the either a hotter or colder star has on where the habitable zone is. Right? For hotter stars, you got to get farther away. So that habitable zone is farther away from the star. Kind of the middle tier in this picture is for stars that are like our sun, right? They have a certain distance that is the habitable zone. And then for cooler stars, right, the habitable zone has to be closer to the star so they get enough energy to stay warm. Now here's what's interesting. is we've found thousands, NASA has found thousands and thousands of what we call exoplanets. And up to date, we know of no other planet that's like ours, that's in that right distance from the sun and what makes up the atmosphere. All right. So we mentioned that the Earth is 71% water. That means everything else that makes up the Earth makes up the other 29%. So of that 71% of the Earth that's water, here's how that breaks down. We have salt water, we have fresh water. Okay? Salt water is most of the water on our planet, 97% and change. Whereas fresh water is just under 3%. But if you zoom in on that blue slice, that 2 3/4% of fresh water, it's divided up into where it sits. Most of it, like almost 3/4 of it, sits in the glaciers and icebergs on our planet. Almost another quarter of it is held in what we call groundwater. And then if you look, that little tiny gray slice and that little tiny yellow slice, right, little tiny percentages of what we call surface water and soil moisture. And so what I'm going to do is, as we go through the lecture today, we're going to explore each of these. But before we do that, Dr. Weil has a great short little video on the hydrosphere and covering some of the things that I've already talked about. So let me have you go watch that and then come on back.